Where is the claim?
H1.
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 Okay. So step 2 is to choose which formula that we need to use. Okay, do we have sigma in our question?
No.
No.
No, so sigma is unknown. Sigma 1, sigma 2 are unknown. The second condition, equality of the population variance. We have equal or unequal?
Equal.
Equal.
Equal. So based on the information that we extract just now, we have sigma 1 equal to the sigma 2. What about the n?
Greater than 2.
Greater than n1, n2 greater and equal to the 30. So we go to the formula with the SP. Z test. So which S bar should be the first one?
On.
On. We have to follow the hypothesis. Okay, it cannot be contradict. Okay, we cannot be contradict. Hypothesis and the Z test here cannot be contradict. If contradict, I will look at to your hypothesis. Okay. So S bar on minus S bar off minus mu naught. Then you have the SP. Okay, 1 minus N on plus 1 minus N off. Betul ke this formula? Let me check. Okay. Okay, so you have to find your SP first and then substitute here, then get your Z test. What is your Z test? You should get. Anyone? Z test?
Negative 0.953.
Negative 0.953.
53.
Okay. Okay, the third step is to find the critical value. So the type of hypothesis we have the type of statistical hypothesis, it is
Right tail.
right tail. Do we need to divide alpha by 2?
No.
No. Okay, so we have the Z test automatically, the critical value should be the Z alpha. So 0.05, the alpha is a 0.05, we have
1.6449.
449.
449. Okay, so this is rejection region. Okay, I just want to recall, and this is the acceptance region. Okay, so step 4. Okay. So you can plot here where is your Z test in this figure. It should be in acceptance or rejection.
Acceptance.
So we have negative here. So it will be somewhere here, the Z test. Okay, so Z test less than Z 0.05. Then do not reject hash null. What happened to the claim? Did we accept the claim or reject the claim?
Reject.
We reject the claim because here do not reject hash null means that we do support the hash null here, and automatically we reject hash 1 and because of claim at H1, so we reject the claim. Okay, so you can write here at alpha 0.05, there is enough evidence to reject the claim that employee perform better during music playing. Any question? Or you can write anything for your conclusion. Okay, you can write at alpha 0.05, there is not enough evidence to support the claim. Also correct lah. Or you can write at alpha 0.05, the employee perform better during the music playing is not true. Also correct. Okay, you can write anything that you want as long as you do support the hash null and reject the claim. So if you are as the manager, should you on the music during the working hour?
No.
No. Okay, so you should not on the music during the working hour based on this hypothesis. Okay, so now we make our decision lah. So no need to turn on the music during the working hour. Any questions so far? Okay, what about my voice? Still breaking?
No.
No. Okay, so we go to the dependent. Sikit lagi nak batal kelas kan? Clear pula suara. Okay, so we go to the dependent sample. Okay, so as what we discussed before in chapter 2, okay, dependent sample, it is where we have two set of data, okay, but from similar population, from similar subjects. So how do we analyze? We combine those two data and then we analyze based on that single data. So how do we combine? We calculate data difference. That's why, so at the end, all the calculation based on that single data. So that's why your parameter will be similar as a single population mean. Okay, the difference is you have the D. So D represent data difference. Okay, so in this slide it should be three formula lah, similar as a confidence interval. Okay, you should have three formula. Sigma is known. Okay, and then sigma is unknown. Okay, when unknown n less than 30 and n greater than 30. So similar as a confidence interval. Okay, so again, the rest of the calculation, the rest of the analysis, it is based on the data difference. Okay, if we back to this exercise just now, how we transform this study to the dependent sample? Any idea? What we can change here so that this study become dependent sample? What we need to change?
Before and after.
Before and after. What before and after? What we can change here so that it will be dependent. Different data. What do you mean by different data? You as a manager, what we can, oh tu menarik tu kalau soalan finance macam tu. Nak quiz. Apa tu? You as a manager, okay, what we can change here so that this study will be dependent sample. This experiment will be dependent sample.
Use the same employee.
Same employee. Okay, we need to use the same employee. So what about the end?
And
When
equal.
we
40 or
must
40.
must be equal. Okay, so for the dependent sample, the n must be equal to each other, lah. Okay, because those two data from similar population. So what we can change here is a employee. So we use similar employee. Okay, we collect the data from similar employee when the music on and also when the music off. Then it will be dependent sample. Okay. Okay, we go to the exercise of the dependent sample here, 3.3.2. Okay, I think it has been discussed in videos that you watch. Okay, but here I just want to highlight that when we have dependent sample, we could have two different hypotheses. Okay, we can formulate, sometime based on the question, we can formulate two hypotheses. So you can decide which one that you want to use. Okay. So which one, which one pula? Apa tu, what is the variable here? What is the variable?
Which question, madam?
Number one. I asked you to do number one kan? Isn't it? Ke nombor apa? Satu rasanya. Safety program. No, it is not safety program here. Do we collect the data about safety program? No. What is the data? It's about
Losses of worker hours.
Weekly losses of worker hours.
weekly losses of worker hour. Is it correct if we write average weekly losses of worker hours? Let me check. Should start the average weekly losses. Is it correct if we write average weekly losses of workers hour? Okay, so average means that we already what we call modified the raw data. Okay, so it is incorrect if you write average. It just weekly losses of the workers hour. Okay, due to the accident in the 10 industrial plants for before and after the installation of an elaborate safety program. Okay, so here these data were collected from same 10 industrial plants. Okay, so that's why it is a dependent sample. Okay, before installation of the safety program and also after the installation of the safety program. So this number of what we call workers hour here, okay, before and after the installation of the safety program. Okay, from 10 similar 10 industrial plant. So by assuming the data are approximately normally distributed, thus the hypothesis at 0.05 level or significant, either the safety program is effective or not. Okay, so the keyword here, safety program is effective or not. Okay, so you have the sample data here, everything that you calculate, you will produce statistic value. Okay, and then it is a dependent sample, means that you have to calculate the data different here. Okay, So which one minus which one depends on your hypothesis that you will formulate. Okay. And then everything that you calculate from the data different, it will produce statistics. So you will have S bar D, you will have SD. There's no sigma. Okay. So we go to the hypothesis. Safety program is effective. How to write the hypothesis that safety program is effective? What kind of sign that we have? Okay. What happened to the weekly losses of the
It's less
worker?
than.
It is less than. Okay. For dependent sample, when we formulate the hypothesis, it is suggested to start from independent sample. Okay, we regard first. Okay, this question as an independent sample. So you formulate first as an independent sample, means that you do have mu1 and mu2, and then we convert into dependent sample. Okay, so convert into dependent sample means that we write into mu d. Okay. So it is about before and after here. Okay, and the variable is about weekly losses of the worker hours. Okay, if the safety program is effective, then these worker hours should be decreased. Should be decreased. Okay, so means that which one is the first population here? Okay, based on this, we need to determine which one minus which one letter for the data difference. Which one is the first population? After?
After?
After. Okay. So it should be mu after less than mu before, isn't it?
Yes.
Yes.
Okay. So the safety program will effective if the worker hour of the after less than the worker hour of the before. So you have mu A less than mu B. Do we have any mu note here?
No.
No, so it is 0. Then you can write in this form mu A minus mu D, and then we bring mu B to the left hand side. So you have mu A minus mu B less than 0. Then we convert into dependent sample, means that we write this hypothesis in terms of mu D. So the whole thing here, it is your mu D. So less than 0. H0 or H1?
H1.
H1. So mu D less than 0, H0
UD greater or equal to 0.
greater and equal to the 0. Okay, when we write the dependent sample here, you need to notify what is your D. So in this case, D mu D is equal to the mu A minus mu B. Okay, you have to notify what is your mu D. So mu D is A minus B. So the next step, okay, for the data different, it is A minus B. Okay, that's how we determine. So where is your claim? Where is your claim?
H1.
1.
That's the first hypothesis that you can write. Okay. When we have this dependent sample, usually we can write more than one hypothesis. Okay, and then you choose which one that you want to use. Okay, both will be correct. Okay. Is it correct if we said Sakti program is effective if worker hour before greater than worker hour after? Is it correct?
Correct.
Also correct. Okay, then you will have mu B minus mu A greater than 0, and this is your mu D. Okay, so you will have another hypothesis here. Mu D greater than 0, mu D less than equal to the 0. Where here mu D is a mu B minus A. Okay, the next analysis, it must be B minus A for the data difference. Okay, so you can choose which one that you want, the first hypothesis or the second hypothesis. It doesn't matter which hypothesis that you use, the decision, your step 4 and also conclusion must be similar to each other. Okay, both must be either reject or do not reject Hashna. And then you conclude similar thing. Okay, the difference only on step 1, step 2, and step 3. Okay, let's say the step 2. The step 2, okay. Okay, we go to the formula, step 2. Do we have sigma here?
No.
No. So sigma is unknown and your n less than 30. So you have to use the theta's. S bar D minus mu naught SD divided by square root n. Okay. Okay. So for the t-test here, you will get similar answer, the difference on your sign. Okay, one you will get positive and another one you will get negative. That's it. That's the only difference. Okay, and then the step 3, okay, the first hypothesis here, it will be left tail, and the second hypothesis here, it will be right tail. But when we go to the step 4, decision must be similar. Okay, both will be either reject or both will be either do not reject. And then of course we conclude similar thing lah. Okay, so that's the only difference. Okay, if you get contradict decision, means that one you reject, another one you do not reject, so something wrong somewhere. Any question? I think the rest I leave it to you. Similar. Any question?
Madam, I have a question
Mhm.
here. So it doesn't mean that the D could be before minus after or after minus before. It is just that the value at the beginning will be different, but at the end when we make the conclusion, it will meet the same.
Yes.
Alright.
So it doesn't matter which hypothesis that you choose. Okay, at the end, the decision and conclusion must be the same one. Okay, because it is based on the same data set, okay, same experiment, okay, same scenario. So decision, conclusion must be the same one. Any more question? Okay. Okay. We go to the 3.4. Okay. Hypothesis testing for the population proportion. Okay. So proportion means that parameter here must be pi, and then you will have pi naught here. So pi naught here must be from 0 to the 1 only. Okay, so if you have in percentage, make sure to convert first. Okay, if your pi naught greater than 1, it is not pi naught. Or maybe you forget to convert into probability. Okay, so similar to the confidence interval, we have single formula only. Okay, and then we use the Z distribution. So here it will be Z plus. Okay, so how to find the P similar? It will be X divided by N, or it is already P in your question. Okay, whenever you have probability of something, or percentage of something of the sample data, it is the proportion. No need to convert into x and then divide by n and then get back the p. No. Okay, sometimes you will end up with the different p that we give you in the question. Okay, and then some student they do mistake on the p, means that it should be the p but you write as an x. Okay, you have to understand the characteristic of the x and p first. Okay, p must be, if you have percentage and probability, it is a p. Your x must be nombor bulat, whole number, discrete number. Okay, it cannot be the percentage, it cannot be the probability. Okay, so do not like you have p but you divide again with the n to get the p. No. Okay, x must be the whole number, discrete number greater than 1 and above. Okay, that's x. That's how we know the value given here. Yeah. Another way to know is based on the question, and also it is a common sign lah. Okay, it is the x or the p. Okay, so x must be the whole number. It cannot be the probability. It cannot be the percentage. Okay. So for this, for the 3.4 here, the exercise we will discuss in 3.5 lah. Okay. So the 3.5 here, we have the difference between two population proportions. So we have pi 1 minus pi 2 equal to the pi naught. So again, it is a z-test. But we have two different formula here for the z-test. Okay, so how we choose? It is based on the pi naught value. Okay, if the pi naught here equal to 0, then we use the first one here. You have to calculate for the pool proportion. Pool sample proportion, it is PP. Okay. If your pi naught not equal to 0, means that we have some value for the pi naught, we use the formula from case 2. Okay. And then compare with the Z distribution. Okay. So different two population proportion, there you will have pi 1 minus pi 2, similar to the mu1 and mu2. How do we decide which one is the first population? It is depends on the question. Okay. Okay, we go to the number 2 here. Okay. What is the variable? What kind of data that we collect here? What kind of data that we collect here?
Major repairs.
Major repairs. Car that need major repairs. So basically, how we collect the data will be like first car, major repair, second car, minor repair, so like that lah. So it is qualitative data. Okay, and then it is clear here we have proportion. So automatically it is a pi. Okay, a sample of 400. This is your what is 400 here?
N.
N. Okay. And for the model 1 and then 500 here.
N.
N2, which is N for the model 2. So N2, the number of owners for model 1 and model 2 who report that their car needed major repairs within the first 2 years are 53 and 78 respectively. So 53 here,
X1.
X1, 78,
X2.
X2. So definitely it is not the P greater than 1. Okay, if you have like Who report that their car needed major repairs within the first 2 years are 53% and 78%, then it is apa?
Proportion.
Proportion. So you will have P1 and P2. Okay. So construct confidence interval. This is here chapter 2. You can do it later. Determine whether the population proportions of car from model 1 that needed major repair is less than 0.25 at 10% significant level. So it is clear that we have proportion. So it cannot be the mu, it cannot be the sigma. It has to be pi. Okay. From model 1. So here we have single proportion or two proportion? Huh?
One.
Single proportion because it is only model 1. Okay. So all the information already extract here. Then Hashna apa dia? Hashna pula. So proportion model 1 that needed major repair is less than 0.25. So pi 1 less than 0.25. Okay, just a simple hypothesis here. H0 or H1? H1. So what about your H0?
I1 is greater or equal to 0.25.
Greater and equal to the 0.25. Which one is your claim?
H1.
Which one?
Okay. So the next step similar. Okay, you have single formula only, which is a z-test. Okay. Any question that you want to ask about that? If not, I just proceed to the C. Okay. So B, the rest of the analysis, the rest of the step, okay, you can do it by your own. If anything, you can ask me, okay? Because you have single formula only, so it is not really crucial, okay? So we go to the C, test the consumer association hypothesis at 1% significant level. Okay, so we need to test the consumer association hypothesis. So go back to the story here. Okay, which one is a consumer hypothesis or what the consumer association say. Okay. So a particular consumer association wants to determine whether there is a difference between the population proportion of the two leading car manufacturers that need major repairs. Okay, so the keyword different. What kind of sign that we have?
Not equal to 0.
Not equal. Do we have pi note here? In the C question, do we have pi note?
No.
No. So pi note equal to
0.
0. So case 1. Okay. So different. Which one should be the first population? We need to write pi what between pi what here? Of two leading car manufacturers. So
Pi 1 tolak pi 2.
pi 1 tolak pi 2. So this is a general one of two leading car manufacturers. So it's up to you. You can do model 1 and model 2 or you can do model 2 and model 1. It's up to you. Both will be accepted. Okay. So the rest of the calculation, you have to follow your hypothesis. Which one that you choose for the first population. Okay. So we can write here pi of the model 1 not equal to the pi of the model 2. Okay, Hashna or H1?
H1.
H1. So H null. H null. Kawan kepada not equal.
Equal to 0.
Pi1 minus pi1 equal to pi2.
Pi 2. Equal 0, pi 2.
Equal to by 2. Which one is your claim?
H1.
Okay, so based on this, pi not equal to 0, so it is case 1. Okay, you have to calculate for the PP. So, okay, so the Z test here, which one minus which one, we have to follow the hypothesis. So, P1 minus P2 pi naught. Okay, let's check the formula. Okay, this one. So pi naught 0 lah. What do you get? Dah buat belum?
Negative 0.9932.
Negative 0.9932.
32.
Sama ya ulang ya? Okay. Okay, step 3. So the type of hypothesis, padu hijau. Okay, step 3. The type of hypothesis apa dia? The type of statistical hypothesis. Huh?
Two-tail.
Two-tail. What happened to the alpha? No need to divide by 2 or not?
Divide by 2.
Divide by 2. So we have this one. Okay, so the alpha just now 1%. Divide by 2, we have
0.005.
0.005. Betul?
Yes.
Okay. Okay, so the value is hijau, the value is 2.
5758.
2.5758.
Hijau lagi ke tu? Okay. 5758. Okay. So we have this value. So mantap hijau. Okay. So step 4 is a decision. Okay, you can plot your Z test here. Where is your Z test? In between or which side?
In between.
In between. So Z test is somewhere here. Okay, when you plot, make sure to label it is your Z test. Okay. When the Z test in between, okay, for the decision here, when we write the comparison, it is compulsory to mention both critical value because it is in between. So compulsory to write that negative 0.005 here, it is a less than the Z test, and then Z test is less than the upper critical value. Okay, so again compulsory to mention both when it is in between. You tak boleh mention sebelah sahaja. You cannot write, okay. You cannot write only z test greater than negative, or you cannot write z test here less than positive. Cannot either one. Okay, you have to mention both critical value here. Kalau tak salah. Okay. So dalam test apa yang buat macam tu? Okay, but okay, the beauty of this figure, okay, if you didn't mention both critical value in your comparison here, I will check your figure here. If you plot correctly, so you will get full mark. Okay, that's the beauty of the figure. As I said before, if you make a mistake in your comparison, I will refer to your figure, whether you plot correctly or not. Okay. So in between, then decision is
Do not
Do
reject
not
H naught.
reject.
do not reject Hashna. Can we write accept Hashna?
Yes.
Yes.
Ya ke? Apa yang tulis accept tu saya tolak ke?
No.
You cannot write accept Hashna because the only reason kenapa we do not reject Hashna here because of lack of the information, not lack of the evidence. Okay, so it is not really accept Hashna lah. Okay, that's why mathematical writing, it is wrong to write accept Hashna. Okay, so step 5, do we support the claim? No, because do not reject Hashna. We support the Hashna here. We reject the H1, automatically we reject the claim. So we do not support the claim. So at alpha 0.01, there is enough evidence to reject the claim that there is a difference between model 1 and model 2. There is a difference in proportion between model 1 and model 2 needed merger repair. Panjang sikit lah. Okay, so you can just copy the question. Any question? Ijo, any question? Kawan-kawan Ijo, any question? So far so good. Tak best lah mengajar tak kenal you all ni. Okay. Next. Okay, 3.6. Okay, hypothesis testing for population variance. Okay, so single population variance or standard deviation. Okay, by using chi-square test. Okay. So because of the variance or standard deviation, then the parameter must be sigma. Okay, if your condition it is about standard deviation, you can write as a standard deviation. It is sigma. Okay, or you can convert into variance, which is sigma square. Okay, it's up to you. Both will be accepted lah. Okay. So because of we have chi-square test, okay, the formula quite similar to the confidence interval. It is just n minus 1, okay, s square divided by sigma naught square. Okay, for the single proportion, for the single population, usually sigma will be given lah. Okay, kalau 0 kat sini memang not defined lah, max error. Okay, so it should be some value of the sigma. Okay. So, okay. So start from here, you have to understand lah. Okay, so the chi-square here, it is a positive distribution. So that's why we have different value for the lower critical value and also for the upper critical value. It is not negative and positive like T and also Z. Okay, so T and Z, it is a symmetric distribution. That's why you have positive part and also negative part. But for the chi-square and also F distribution letter, they are positive distribution. So even though you have the left tail, the critical value must be positive. Okay, because in general, the chi-square and F distribution, it start from 0 here. Okay, that's why even though you have the lower critical value here, it is positive. Okay, here. Okay, so if you have to tail, it is chi-square 1 minus alpha over 2 and no. Okay, if you have one tail, only the right tail, then it just alpha. No? It just alpha. Okay, and positive. Okay, it is not negative value. Okay, so we go to number 3. Done? Okay. What is the variable? Variable?
Height of a ruler.
Height of ruler or ruler's height. Okay, this is your variable. Okay. Number I ask you to do number 2 or number 3? I think number 3. Tak apalah, we discuss number 3. Okay. Okay. Okay, so you are given the height of a sample. Okay, of 10 rulers produced by the process is given as follows. So this is the sample value. Okay, automatically anything that you calculate from this data, it will produce statistic value. Okay, so you will get S bar. Okay, if you need the mean, or you get the S. Can we stop the process at 0.1 significant level? Okay. So the keyword here, stop the process. So how do we decide this? By using hypothesis testing. So stop the process, go back to the story here. Okay. So stop. If the variance of the ruler height is not equal to the 2, the process will stop immediately. Okay. So you are given condition of variance. Okay. Condition that related to the variability. So it is clear here, if the variance is not equal to the 2, the process will stop immediately. So automatically parameter will be, parameter for your hypothesis will be Kemudian parameter dengar ke tak suara saya? Can you hear me?
Sigma square doesn't equal to 2.
Allahu Akbar. Kena tanya dulu, dengar ke tak? Stres dan. Apa dia tadi tu? Saya tanya apa parameter? It is must be sigma square lah, because it mentioned that it is variance of the ruler height. Okay. H0 or H1? So sigma square not equal to the 2. H0 or H1? H1. Claim. Claim apa? Kat mana? Can we write this one? Can we? Can we? Can we write this one? Yes, also can. Okay, you can write as a variance or you can write as a sigma. But because of you are given variance, then just use the variance. Okay, if you are given standard deviation, then use a standard deviation which is sigma. Okay. If you use the sigma here, automatically the sigma node here the sigma node square here must be converted into sigma lah. Okay. Okay. So step 2, calculate the chi-square test. N1 minus n minus 1 s square divided by sigma square dot. Okay, dapat apa? S square you can calculate from this data. Siapa yang dah buat? What is your chi-square test? 0.4389. Okay. And then step 3, critical value. So we have two tail. Okay, so alpha divided by 2. So alpha is a 0.1 divided by 2, 0.05. So the new n minus 1 which is 9. Okay, 1 minus alpha over 2, 0.95 and 9. What do you get? Lower bound and upper bound? Apa critical value? That's the upper one, eh? The lower one? Okay. Okay, step 4. Where is your chi-square test here? Less than lower. Okay, so we have 0.43889. So somewhere here, less than lower critical value. Then decision. Apa decision?
Reject H0.
What happened? Claim? Did we accept the claim? Did we support the claim? Do we support the claim?
Yes.
Yes. So should we start the process? Should we stop the process? Yes. So at alpha 0.1, okay, so you can write your conclusion in this form. So at alpha 0.1, the process can be stopped immediately. Any question? Okay. Okay, so we go to the last one for today. Okay, the last one for this week, we have the hypothesis testing for the ratio of two population variance. Okay. So for the ratio of two population variance, okay, so that's why we have sigma 1 square divided by sigma 2 square, similar idea as a confidence interval. Okay. So for the hypothesis testing, how we need to write the hypothesis testing? So you can write in this form, sigma 1 equal to the sigma 2, sigma 2 square. Okay. Or you can write in the form of ratio. Okay. So hash null sigma 1 equal to, I will write here now. Okay. Other than you have okay, or you can write in the form of ratio. When you write in the form of ratio, automatically the sigma naught square equal to 1. Okay, so for this case, for the case of the ratio of two population variance, sigma naught square always 1. Dia tak boleh 0. If 0, undefined lah kat sini. Okay, it must be 1. Okay, so for the ratio of two population variance, sigma naught square always 1. Okay, because of this lah. Okay, so in this case we use the F task. Okay, similar idea as a confidence interval. So it just S1 square divided by S2 square. Okay, and then similar as a chi-square task. Okay, okay, for the critical value. Okay, let's say that we have two tail. Okay, so after similar to the chi-square, there are positive distribution. So it start from 0. Okay, the upper critical value you have F alpha over 2, no 1, no 2. So it is different from confidence interval. Confidence interval we need no 2 first and then no 1. But for the hypothesis testing, we have no 1 first and then no 2. Okay, it is a theory behind that lah. Okay, so for the lower critical value, it is F1 minus alpha over 2, no 1, no 2. Okay, so because of 1 minus alpha over 2 is not in our statistical table, that's why we use the formula. Okay, so it is equal to the 1 over F alpha over 2. We need no 1, no 2, then it will be no 2 and no 1. Okay, and the rest should be easy lah. Okay, the crucial part only on your critical value. Okay, so we go to the exercise. Okay, the number 3 here. Okay, what is the variable? What is the variable in this question?
taken to assemble a unit of the product.
Time taken to assemble one unit of the product on each type of machine. So we have quantitative variable here. Okay, time taken to assemble one unit. Okay, so we have machine A and machine B, just a part of product from machine 1 and machine A and machine B. So this is a sample data. At 10% significant level, test the difference in variability between the two types of machine. Okay, different in variability, the keyword here variability, automatically it is sigma. Okay, sigma square. Okay. So between sigma or sigma square, both will be accepted. You can use a sigma square or you can use the sigma. Okay, both will be accepted. Okay. Variability, it is not the mu, it is not the pi. It has to be sigma or sigma square. Okay. Different in variability. Different means not equal. Okay. Between the two type of machines, so it's up to you. You can do machine A first and then machine B. Okay, so here you have pi square A, sorry, pi pula. Sigma square A not equal to the sigma square B. H0 or H1?
H1.
H1. Okay. And then H0 opposite to that, sigma square A. Saya pula tulis terbalik lah. Okay. Where's your claim?
H1.
H1. Okay. So the next step similar because of we have single formula only. So it just atas S1 square divided by S2 square. Okay, so because of we choose A first and then the atas must be SA square divided by SB square. Okay, the rest I leave it to you. Okay, if anything you can just ask me. The B question, okay, A and B related to each other. Which machine should be installed by the company to assemble its product? Test the hypothesis at 10% significant level and use the assumption of the condition of variance equal or unequal based on your answer in A. Okay. Which machine should be installed? Okay, so we go to the story here. The company will install machine B if the mean time taken to assemble a unit of product is less than the mean time taken by machine A. How the hypothesis here? What parameter?
Mu B
Mu
minus
A.
mu A less than
Mu
0.
B minus mu A less than 0. So it is clear here we have a mean. So we have mu B minus mu A less than 0. H0 or H1?
H1. H1 madam.
Okay, so claim at H1. So let's see how this question relate to the A question. So the step 2 is to choose the formula. So we know that when we have different mean here, I mean different mu here, so it is an independent sample. So to choose the formula for the independent sample, the first condition that we need to determine is, the first condition that we need to know in order to choose which formula we need to use. Apa dia? The first condition. Baru je cerita. Apa dia? Anyone? And before the N.
mu1 and mu2 is unknown or unknown or unknown.
Mu1 or sigma?
Sigma.
It is sigma. So the first condition we need to know. Sigma A and sigma B unknown or known. In this case, known or unknown?
Unknown.
Okay, go back to the question. It is unknown. You are given sample data again, anything that you calculate will produce statistic. So unknown. So the second condition, apa dia?
N is less than 30.
Before that. Before that, before the end, what condition that we need to know?
Sigma is equal. Sigma1 and sigma 2.
Equality of the population variance. Adakah mention dalam soalan?
Dah kira dekat A.
Kira dekat A's. So the condition of the equality of the population variance here based on question A. Okay, because here we state that use the assumption of condition of variance equal or unequal based on your answer in A. So this hypothesis. Okay, so after you done, okay, your decision, you reject Hashna or do not reject Hashna. If you reject Hashna, let's say that in A, okay, decision is reject Hashna. So this reject Hashna, which one that we support? Equal or not equal?
Not equal.
Not equal. So means that sigma A not equal to the sigma B. If you do not reject, it is sigma A equal to the sigma B. So this apply to this. Okay, based on your answer in A, we choose whether we have equal or unequal. So B depends on A. Okay, question B depends on question A. So the answer for the B here, there is no right or wrong. Means that, okay, it is based on the A, whether you accept equal or unequal. So it will follow the answer from A. Okay. And then after that, it is your N, and A and B less than 30. Okay, so can you see how it is related to each other? So this is what I mentioned when we discussed 3.7. These conditions sometimes you have to test. If it is not in your question, then you have to test first. Okay. If it is in your question, then use as it is. Okay. If not, then you have to test. Okay, so this is a guided question. Why guided? Because first we ask you to do the difference in probability first. And then the B here, we have to use, you have to do the mean, the independent sample by using based on your answer in A. Sometimes it is not guided question. You have to figure out by yourself that here you need two hypothesis testing. Okay, you need to perform two different hypothesis testing. First for the ratio of two population variance and the second one for the independent sample. Okay, if you go through the tutorial question, I not remember the question, the number of question, but the beginning of your tutorial question. If I'm not mistaken, the question is about alloy. Okay. you can find in your tutorial question. It is independent question with the unknown case. So you don't have the condition of equal and unequal population variance. So you have to test first. Okay, test the ratio first and then go to the independent test. Okay, so when you have this kind of question, one thing that you have to confirm, the alpha here. The alpha here that you need to check. The alpha here and here must be similar to each other. Okay, if the alpha here different from the A, let's say that here you have 5%, then kita tak boleh pakai your answer in A because of different alpha. Okay, in order for us to use the answer in A, alpha in B and A must be similar to each other. Okay, so if we change the alpha in B to the 5% here, means that you have to test another hypothesis for the ratio with alpha equal to 5%. Okay, so both question must be similar alpha. Any question so far? The rest of the calculation, it is yours lah. I leave it to you. Okay, just a easy calculation here. Any question? But you need to understand what happened in this question. Okay, why A and B related to each other? Okay, without A, you cannot answer the B. Okay. Any questions so far? So we are in week 7. 7. Hopefully we still excited about this subject. Okay, we still have excited lah about this subject. So that our class will be not too bored. Okay, excited, memang excited. Okay, so we try to make sure our class, our virtual class is what we call interesting lah. Okay, not really boring sangat. Okay, that's why I need your cooperation. Okay, participate in this class lah. Okay, so if there is no question, okay, that's all for today. Thank you, class.
Thank you, Doctor.
Okay.
Thank you, Doctor.
I'm just curious whether you hear me or not.
Thank you, Doctor.
Okay. Thank you for today. See you next week, insyaAllah.
Thank you, Doctor.
Okay.
Thank you, madam.